we want to compute the following sum using just algebra and the rule of the sine and cosine. Okay, so this is the sum cosine squared of pi over 12 plus cosine squared of 3 pi over 12 plus cosine squared of 5 pi over 12 plus cosine squared of 7 pi over 12 plus cosine squared of 9 pi over 12 plus cosine squared of 11 pi over 12. So to compute this sum and make it easier, there are many rules, but for us, since this sum is small, we can use just the formula that let us transform from the square to just linear addition. What do we mean by that? So we know that the cosine 2x is 2 cosine squared of x minus 1. Okay, we're going to use this rule here to simplify this sum. So here, if we add 1 to both sides and we divide by 2, we get 1 plus cosine 2x over 2 is cosine squared of x. Okay, the aim of this formula is to get rid of this 12 here, because here we're gonna simplify the expression for the angle. Okay, so if here we have x, in the reduction we're gonna have x over 2. Okay, so we're gonna multiply here. So this is pi over 12. When we do this formula, we're gonna get pi over 6. Let's do it exactly. So here we're gonna start with this one. The cosine squared of pi over 12 is, according to this formula, is 1 plus cosine of pi over 6 over 2. Okay, because we multiply by 2, therefore we divide here. Okay, the next one is cosine squared of 3 pi over 12. The same thing here, we get 1 plus cosine 3 pi over 6. We're gonna simplify this expression more later. So the next one is cosine 5 pi over 12. So this is 1 plus cosine 5 pi over 6 over 2. The next one is cosine 7 pi over 12, which is 1 plus cosine 7 pi over 6 over 2. The next one is cosine 9 pi over 12. So in this case, we get 1 plus cosine 9 pi over 6. No simplification for now. So the last one is cosine 11 pi over 12, and we get 1 plus cosine 11 pi over 6 over 2. Here, I'm going to put the 1/2 on the side for all of them. The 1/2, we're going to need it. Okay, 1/2, plus here we start simplify. Cosine pi over 6 over 2. This one here, cosine 3 pi over 6, that's cosine, let's keep it simple, pi over 2 over 2. Let's not say anything about that. Here we get cosine 5 pi over 6 over 2. And this one here, cosine pi plus pi over 6, okay, over 2. And this one here, cosine of, let's simplify this one here. We can let me write it, because I need it for some of the formulas, because I want to cancel. So the best way to get rid of is to write it in the okay, let's see how we can write this one. Okay, so it's gonna be, let me do pi. Okay, let me write it 3 pi over 2. Okay, so we can't write it anymore, we can't simplify it anymore. And here, cosine of this one, it's gonna be, how to simplify, which one we can simplify. So we're gonna get pi plus 5 pi over 6. Yes, I think so. Yes. So this is what I need here. So cosine, let me start simplifying. Cosine pi over 2 is 0. So we don't need this one. Okay. The cosine of 3 pi over 2, okay, so that's 0. We don't need this one. Okay. Now here, the cosine of pi plus pi over 6 is minus the cosine pi over 6. So this one is gonna go with this one. So that's why I stopped, because I have to think about how to write it better, so to make it easier. This one is gonna go with this one. And finally, yes, this is right. So this one, cosine pi plus 5 pi over 6, is gonna be minus the cosine 5 pi over 6. I forgot my 2, but it doesn't matter. So this one is gonna cancel with this one, because this is minus cosine 5 pi over 6. All I'm left with is these ones, 1/2. How many one of them? So I have 1, 2, 3, 4, 5, 6. So that means the sum s is gonna be 6 times 1/2, which is 3. Okay. So in fact, this is we can prove this formula in general. We're gonna do it later. Assume that we have this sum. Okay. We're gonna write it as the cosine squared k pi over n, with k from 0 to n. Okay. I claim that this one is n plus 1 over 2. Okay, because here, yes, I think so. Or n over 2. Assuming from my assumption here, we're gonna prove this one later. Why this one? Because we need this one for Fourier series and other the sound amplification. Okay, if we wanna do that. So this is, so I'm not sure if this is the right one, but I will try to prove it by either induction or in general, using some complex analysis, complex numbers. Okay, thank you very much for now.